Hello there. This is my 50-year-old Data General mini computer. I have been working on restoring this thing over the last couple of months, tackling the terminal, the computer, and the disk drives. At times needed to get deep into circuit-level diagnostics to find low-level issues. But it's now all fully functional and ready to go back in the rack. Well, mostly fully functional. Turned out that my second serial card had a bad 603 custom Data General chip that there just aren't equivalent replacements for, but luckily I think I got one that I'm getting some help with obtaining. Thank you, Playful. And I should be able to fix that in the future. But for now, the thing is completely fully usable, so we don't have to worry about that. But today it's time to finish off this microNOVA series, get it back in the rack, and show you what it's like to use. Now, before we begin, I'll mention that I haven't yet tackled the hard drive. I've been setting up the system to be completely usable without it, mostly so that it would be ready with software to go once I have the hard drive up and running so that I could get the data off of it without needing to rely on it. I am pretty sure the original operating system for the computer is on the fixed disk platter underneath of this removable portion. And it's an earlier version that is archived anywhere else based on the bootloader that's on my one software disk that I got with the machine. So it's going to be important that I have everything ready once I try to spin this thing up for the first time. But I'm not ready to do that yet. So we're going to leave this be. This is going to take a whole other load of work to get going. And for right now, I don't need to do that. And I think we need a break here for a little bit. So we're going to postpone that for now. Now, it was some time ago that I originally took the microNOVA computer out of the rack, but I still remember the pain of it. These vertical mount rails in the rack aren't threaded, and there are no sliding rails on the microNOVA chassis itself. It gets threaded into bolt clips in the rear, and in the front there are these awful little metal bars that are a pain. Now, I do want to get the computer back in the rack next, but bear with me while I try and film this because I'm not even going to be able to see the stupid little metal bars, let alone get good camera angles for you all. So I'll try to show you as much as I can, but it's going to be pretty rough. First, though, I need to get the panels off of the rack, and I really, really love the whole design of everything here. Data General just absolutely knocked it out of the park. The panels sticking forward out like this with the curved edges, just it's also excellent. Now, before I put the computer itself back in, I need to reattach these two plates to it. I believe they go on like this. No, this, I'll figure it out. But I wanted to mention this part and these two wires because my microNOVA originally came configured with the power fail option. And if you remember all the way back to the video where I first took this out and tore it down, I removed the batteries from it. Now, I do still have them just for kicks. Now, interestingly, power fail was already disabled on the CPU card, it turned out, for some reason. So I don't know if these batteries were bad while it was still in use or not, but I'm not even putting them back in because I don't want to risk them leaking. So I have the empty power fail battery tray here, and I never plan on putting it back in there with batteries. So, but I do need to get these back on because they support the back of the computer in the rack. All right, now to align this in there, I'm going to drop the computer onto the hard drive and then slide it back because it basically goes there. I'm going to be very cautious. You know what? I'm going to push it slightly farther back so the tip rail can catch on the board there because it's going to be a lot of weight hanging off. Did I have to take these off before removing it? Because these don't look like they're going to go in. I hate how this mounts. Oh. All right, after reviewing my footage from doing this before, yeah, this is just awful. I'm going to take off the top, and we're going to remove both side panels again. I'm going to slide it in through the front. I'm going to put the metal pieces on actually before that. I just looked at these, by the way. Turns out, you can't see it on this one, but they were taped on. You can see the glue left over on there. These were taped to the racks for the initial install, I can't recreate the tape like that, or at least not in good conscience, because it's gonna fail again. So I'm trying to zip tie these in place, but that's not awesome. So I'll see how it goes, because it doesn't align them very well, but yeah, it should be taping them in. There we go. So that'll let me get into here to actually reattach those metal side plates. That wouldn't have been possible without this. Also realized in the video that I took off the front panel as well, so I'm gonna do that because that looked like it made life a lot easier. Now I'm gonna get these metal bars secured and then I'll start putting it back in there. All right, I think I've got the rail situation sorted. This really is kind of a huge pain in the butt. This is the only one that's not great. The other ones I put twist ties through the front and re-angled them over to the side. I'm hoping that'll make it so that I can get the screws through the front of this thing and then have it work. So we'll see how that goes. All right, I think I'm gonna be able to nail this here. That one is definitely in. Oh, that might do it. All right, it's all in, at least seated here. They're not fully tightened. I'm gonna need to lift this side, but I need to put the door back on first, and I might want to also put the rear supports in too, because I mean, the whole thing just, there's a lot of tightening points, but I want to make sure that the door will open cleanly and not catch on this and on the top piece of plastic that I also took off. So I'm gonna have a lot of fitment things to balance here for a little bit. So I'll join back in with you once all of that's taken care of, because it's just gonna be a lot of fiddly work. Oh. Of course, literally at the last possible minute is when this thing snaps off of here. So now I have to take off the door and try and resolder the contact that just snapped off of here. That is not going to be easy. All right. I've known this was gonna happen for a while. I just thought I was gonna avoid it for now. There, that'll at least hold for now. And I don't really need it to short out on every other possible thing. Okay. Oh, there. The microNOVA is in. I think everything is cinched down. I need to tighten this still. I didn't want to fully tighten it so I didn't accidentally destroy it. But you guys remember that CRTEdit comic where someone asked the programmer to do one thing? It's like, sure, yeah, I'll have it done by Friday. Then they ask them, also, I need another program that can identify a bird in a picture. And the programmer's like, I'll need a research team in 5 years. Putting the microNOVA in is identifying the bird. Installing the floppy drive is the other task. Once I know the cables are in there and aren't going to get caught on anything, floppy drive's actually on rails. So once it's aligned, that's it. That's it. It's installed. Almost makes me mad how hard it is to put in the microNOVA. All right, technically there's supposed to be this trim piece that goes down here too, but I forgot how much of a pain in the butt it is just to attach this, because it screws into the back plane, but the screws come in from the back, and the metal is shaped in such a way that it is completely covered. So I can't get a screwdriver straight onto the Phillips bolts. So I want to think about how I can attach this in maybe a less insane way for a little bit here. Maybe I can find some magnets that I can put on there and then just stick it on or something instead. So I'm going to leave this off for right now. Okay, it's all in the rack now. Really glad to be past that nightmare. I thought I remembered how much of a pain it was to get the microNOVA in here, but I was very clearly wrong. So, but now we're at the point where I can get it all connected, and there are a few things about that I want to go through. It is not easy to film back here, so I'm going to be doing most of it with my phone, but at least the top does come off. I forgot about that. So there's some stuff I'll be able to film here that will actually make sense for you to see. So let's start on everything on the back now. Oh, the phone is so much better for this anyway. Now, the first thing I want to cover is power. Now, the door of the rack has this handy little diagram printed out, and the microNOVA rack is 115 volts. This is not true of the Nova 4X rack, but the 115 volts still uses a weird connector. Now, I could probably get an adapter to go from that connector, but that goes through I don't know, whatever is in here. It might just be a distribution block, and then ends up in this conduit. Now, the thing is that everything that I'm going to be running, not including the hard drive for now, which I'll talk more about that, I have the cover off for a moment, is only going to draw a little over 400 watts. I measured it. So it's not really a concern at the moment. So for now, what I'm going to do is I'm just going to take the individual power cables and I'm going to stick them through this rubber grommet panel thing here. And I'm going to plug them into a power strip just kind of between the two racks. So that will let me power everything here without going through the complicated conduit thing. All right, now let's talk about the backplane, the hard drive, and the floppy drive. So the floppy drive has the fixed cable coming out of it, and that ends right here. Now, originally, this was actually plugged in right here on the backplane of the hard drive. And then the other side of the floppy, well, actually, this would be connected to the other connector inside of the floppy drive, but the side that this is connected to would then go up to the backplane to connect like normal. This had the terminator on it, but I'm currently not using the hard drive, so I've moved the terminator into the floppy drive, which means that we're now going to bypass the hard drive entirely. Keep in mind that the microNOVA architecture here is designed for daisy chaining, so you can go from the computer's backplane to the floppy drive, and then from the floppy drive to the hard drive. This board right here is the Data General 6059 hard disk controller. That's why this connects to the backplane. I believe what is here is effectively the control signals that go to the hard drive itself, which is a 6045. Interestingly, the same drive that I have over there in the 4X chassis. So that's why we're able to just go straight to the backplane, and why I don't have a disk controller card in the microNOVA. The same thing here, that top board on the 6039 is the disk controller itself that interfaces directly with the backplane. So this is a kind of cool setup. Imagine having a PCIe device that is external to your computer and has its own integrated controller, and now you're just thinking of USB. Well, Thunderbolt, but still. Pretty cool that this concept was being done all the way back here. Now, with all that said, this is the only cable that I need to connect for the floppy drive to communicate with the computer, and we plug it in right here into this seemingly unimportant spot on the backplane. It is documented in the manuals, and my original reference photos for it do go right there. Next, I want to talk about the serial card and how we connect to that, but I think it would help to know a little bit more about the computer's components. The lowest card that goes in the backplane is the CPU card. On the microNOVA, this card has a custom integrated CPU that merges the 4 chips needed for the bit slice architecture that you can see on other Novas. This card also contains a small amount of RAM that allows the computer to be minimally usable without any other cards. This is the card that I needed to repair to solve an issue that was preventing me from being able to write to RAM. Now, the next 4 cards I will be installing are all dedicated RAM cards. When I got this machine, it was configured with the maximum amount of memory it can have, which is 64 kilobytes, or in data general parlance, 32 kilowords. Now, all 4 cards that I'll be putting in here are jumpered for specific address ranges. Now, Data General uses octal notation for everything in the low-level hardware, which is a little weird. And when you see me using the console debug option, you'll notice that there is never a number greater than 7, because octal are just values from 0 through 7. Now, as part of that console debug option, I've actually ended up creating a modern computer host program that can read and write to ranges of memory on the Data General. And this works thanks to one of the 2 asynchronous serial interface cards that I have. We'll only be using one of these because the other doesn't work for right now, and I won't be reinstalling it. But the one with more parts on it is the more important one anyway. The extra components on it make up the console debug option. This is what the basic interface is that the machine will boot into before loading an operating system. Now, this machine can be used without the console debug option through 2 other methods. One is a ROM card and setting an address range on the CPU to have it directly execute any code at that location. The other is the handheld console, which is a small keypad that would be mounted to the front of the computer. The handheld console is way cooler, but it's not as functional as the serial debug console, so I don't mind that I have that option instead. Now, on the serial card, there are also jumpers for configuring the usual serial settings like baud rate, parity, and word length. Before we put the serial card in, though, you can see that it has an extra set of contacts on the rear compared to the other boards. And that's why I needed the card to be installed in here first. On the rear of the backplane, I can install the serial connector, which wedges in between 2 spring steel plates that attempt to hold it in place. I've also made a second channel video if you want to know more about the adapter that I put on this cable that lets me use it with regular DE9 hardware. All right, we have the computer and the drives back in the rack. Everything's connected, so it's time to put the panels back on. I'm really excited to have this thing at full dress now. Kind of mind-blowing. It's sitting here and it should work. Like, I've seen this for 5 years now, and the thought has always been, oh, yeah, that doesn't work. But now it works. Now, this is going to be my first time ever powering it inside of the rack, and I'm really curious to hear how it muffles the sound because, well, especially the floppy drives here have a really bad 12 kilohertz whine, and I'm hoping that it muffles that. There is one problem running it in the rack. Technically, that internal rack conduit thing not only is power distribution, but it powers fans that run through there. And the machines might not like not having the fans circulating air through there, so that could be a problem, but I am running it in an air-conditioned office, and let's be real, I'm not going to be running them 24/7, so hopefully it's never really an issue. But I don't plan on trying to power those fans for the moment. We're now ready to set up the terminal, which for this machine is going to be a Data General Dasher 6053. A side note, in the past I've called this a D2, but that's not quite right, although it kind of is. It's a little weird and confusing. So I've done a lot of reading in Data General manuals and stuff, and I think the Data General Dasher D2 is just a rebadge of this terminal, which is the 6053. The Dasher D1 is a rebadge of the 6052, which is just a slightly different configuration of this machine that only has uppercase characters. So this would be a 6053, not a D2. And so with that one, a huge shout out to AJ from Forgotten Machines, who hooked me up with that Dasher 6053. I have had to go through and fully restore that one. I figured we've already seen that on video with this one. So I streamed the process, but I'm not going to edit it into basically the exact same video that we watched like 2 weeks ago. So thank you again, AJ. But also a huge shout out to Bill Sudbrink and Commodore Z, because that didn't come with a keyboard, but I should have one pretty soon for it, and I'm really excited to complete that machine. Now, the next part of actually setting up the terminal with it is a little weird. Now, it would make sense to put the terminal on top of the machine, but you can see there are vents on here. And for one, I shouldn't block the vents, although because I'm not running the fans in the case, it's not gonna matter a ton, but it will allow the heat to convect out. But two, the keyboard and the base for the monitor both have these giant rubber feet on them, and I don't want them being put on the vents and getting marked permanently on the bottom. Now, for storage, I am, of course, going to end up putting the terminal on there, so I have a towel that lets me put the base on here without worrying too much, along with the keyboard. Now, a configuration similar to this was intended for use with the microNOVA, but not with this rack. There was a different rack available that had a wood top for you to put the terminal on. That's not what I have here, so I don't really want to run the machine with it up there. So for now, I'm going to use a different setup. Just for now, I'm going to have a table set up next to this. It's not going to be the best table, but this will let me have access to the floppy drives while we're trying to load software on here. But there is a table that is meant to go with this thing, and I want it something fierce. In one of the install systems guides, there's a diagram of a data general table that you could put the terminal on. I've even used the dimensions they gave here to try and CAD my own version. I even bought a random data general book about advertising just because it had pictures of this table. Look, it can have disk storage. I might end up building that thing someday, but for now, I'm just gonna have to settle for my folding table. All right, now I'm gonna have the computer and the terminal both set to 19200 baud, but I'm also going to mention here that the Dasher has composite video out. So I'm gonna be getting screen capture of the terminal itself as we continue from here. All right, we're ready for the first full fire up with it all in the cabinet. So here we go. It's pretty quiet while it's in there. That's not bad at all. Oh my gosh. That is so awesome. It's working. I mean, all of the components have been working for a while, but like, this feels more real. Now, next, I want to go from just having a machine that sits here and, I mean, yeah, I can read memory on, that's cool, but I want to show you how we can go from this to this, a booting computer running an operating system. So let me walk you through the process that I had to go through to get an operating system running on the microNOVA. All right, we're over here at a modern computer where I have a set of 8-inch floppy drives. These are CUMTRAC 842 drives that are double-sided 8-inch drives connected to a grease weasel that will allow us to write new floppy disks for the microNOVA. But before we do that, I was able to image my one useless boot floppy that I got with the machine as pure flux, which was a critical step of what we're now able to do. I was able to provide that flux sample to Kirf from the Grease Weasel project and Peter, one of my viewers, who created an initial pull request to get data general data decoding into the Grease Weasel software, which is a massive help for doing this stuff because data general stuff is just weird, and reading and writing floppies is a pain in the butt. Also, shout out to Zero Ohms, who helped me with some other tools during this process. Now, like I mentioned, we're going to use this setup to create some new floppies for the Data General microNOVA to get its DOS operating system running. Now, RDOS was another version of the operating system that was available for these machines, but at this point, I should take a moment to address the DOS name. This computer's from 1975. Microsoft DOS did not exist yet. RDOS and Data General DOS are in no way related to anything that Microsoft ever made. DOS just stands for Disk Operating System and was a very common term before Microsoft used it for their product name. So this does not have anything to do with Microsoft DOS compatible systems or software. Just let me know that. Now, we're only able to attempt to make this thanks to the awesome preservation efforts of Bruce Ray, who runs Novas Are Forever. On his site, we can find a magnetic tape backup of a microNOVA compatible DOS. Now, I don't have a magnetic tape drive, and realistically, I'm never going to find one because the microNOVA is extremely weird amongst the Novas, so it would need to be a microNOVA mag tape drive. And even just getting a normal mag tape drive isn't easy because you need the matching drive and controller card. But there is a way that we can use SimH to convert the mag tape files into something we can work with on floppy disks. SimH is a computer emulation system similar to how MAME works for arcade games. It emulates many different computers, but we're going to use the Nova runtime. Now, I'm not going to get too deep into this because SimH is a very complicated video. Let me know if you'd like a second channel video taking a deeper look into how to set this up, because I'd be happy to do that. So for now, I'm just going to kind of gloss over some of the basic details as to how I'm able to do the magnetic tape to floppy disk conversion, just so you can kind of follow along. Now, here I have my SimH configuration file, and we're going to start out with a hard disk image that already has RDOS pre-installed on it. We're not going to use anything from that hard drive, though. We just need it to boot SimH. The next thing we need is a blank hard disk image and 2 blank floppy disk images. I'm going to make 2 copies of the blank disk, one labeled boot and one labeled util. Okay, it took me a little longer to figure out the next step. I've done it before, but you just have to get the right commands in the right order, and it's weird. Thankfully, I have been able to acquire a number of original data general manuals that all help with this. It's nice to just have the stuff, boom, right here, ready to use. So, all right, now I've configured SimH to have a magnetic tape file loaded here, and we're gonna be able to start our simulation with a shortcut that I've added here that allows me to just run the Nova program with the script that I have written here. And now we're going to switch over to the blank hard drive. We're going to init the magtape drive, and now we can do load nmt0 with the file specified here. Now the magtape contains data that are files that are very similar to how tar works on Linux. So this is saying we want to access file 0 on the tape. However, file 0 is useless to us. We actually need to start with file 1. We need to extract all of the data from files 1, 3, 6, and 7. I have no idea why those are the ones that we need, but that's what we need to do. So I am going to get all of those extracted now. All right, after getting all of those files off, we can list our hard drive now, and we can see a ton of files on here. Now, we couldn't fit all of these files onto 2 floppy disks if we wanted to. We're gonna have to sort through these and only get a handful of files. But thankfully, there's a manual that tells us what files we need. And that is the How to Generate Your DOS System manual. On page 16 here, we will find a list of files that go on the starter diskette, and on the next page, we'll have the utilities diskette. So that's why we're going to be making 2 disks. One will be our starter disk, and one will be the utilities disk. Now, I'm going to cheat slightly because I have already made these disks, and I'm going to use my old utilities disk, but we are going to recreate the starter disk so I can walk you through that process. Now, I've already made a list of the files here and the commands that I need to run to move those over to our floppy disk. And we can make sure that the floppy disk is accessible here with init dp2. We can dir over to dp2, list it, and see there are no files on it, which is perfect. We need to dir back to dp1, though, due to how the move command works. Now, move counterintuitively actually is a copy command. It's not going to take the file off of the hard drive, but that is what it is. But now I can copy these commands, paste them into SimH, and have it make our disk by moving the files that we need over. And there, that is all of the files that we need. Now, there are some additional files on here that we're not copying. For one, the mboot sys and these files are different between a microNOVA and a standard Nova, but also we can't fit DOS in it on here because this manual is actually written for a slightly different version of the DOS operating system than the one that we're using. So the files that are on this disk aren't quite the same, but this is going to be enough for us to do what we need. Now, there's one more thing that I need to do to this disk to make it a fully functional starter disk, and that's write the bootloader that lets the computer actually boot from the floppy. But I can't do that in SimH because it's not emulating a real microNOVA. Now, this puts us into a kind of catch-22 position because I need to be able to write the bootloader to be able to make the disk boot, but I can't boot the disk to be able to write the bootloader. Thankfully, that one boot floppy that I have right here was a solution to this problem, because this contains the bootloader. So once I was able to decode the data on that disk, I had a copy of a valid bootloader, and we could just use a hex editor to write that onto the disk image before we write it with our floppy drives. Now that we have our image ready, we can write it to a floppy. At the time I'm writing this, though, the data general support in Weasel hasn't made it into a published release of the Weasel software yet. So I'm running a test version compiled directly from Git. Writing the floppies are a little more complicated than just a write with a format, though, because the 6039 uses hard sector disks. There are multiple holes along the track index indicator that tell the drive a sector is coming. This throws off the soft sector interfaces, thinking each track is very short. The Weasel has a hard sector flag, though, to support this. With that, it's trivial to write a disk image from SimH to a real floppy now. And go. With this floppy and, the other util one, we now have everything ready to use the microNOVA. This isn't itself the final OS, though. This is just the installer, but we're going to do everything else from here on the real hardware. All right, we're at the real hardware, about to boot it, but there's actually one more thing I need to do with the floppy and the Weasel. It's not possible to fully format a new disk on the microNOVA. Data General wanted to sell you pre-formatted media and didn't include the ability to make it yourself. Thankfully, with the Weasel, we can lay down the low-level sector data. So anytime I need a new disk on this machine from now on, I'm going to be using a modern computer to initialize and format it, and then I can stick it in the microNOVA. All right, let's fire up the computer so we can start this process. Okay. All right, so here we are at the computer with the starter disk that we made and our blank disk. So I can put the starter disk in the left drive here, and now we're ready to begin booting the computer with that. I'm gonna put the blank disk in the right drive, and now we're ready to try and get an operating system configured and running on the microNOVA. Now, to make the computer actually boot from that disk, I'm going to have to enter in the device select code for the program source, which for the 6039 floppy drive is 33. Then we send it capital L, which acts as a command to load. The file name printed there indicates it has successfully loaded the bootloader off of the floppy disk and is asking us what we want to boot. To set up a system, we can follow the how to generate your DOS system guide. Now, as it's asking for the file name here, we're going to tell it boot. This is the bootloader writing program that we couldn't do in SimH. We have to write the bootloader to the new floppy disk that we're making so it will be bootable in the future. Now we need to use the device specifiers. The drive we are booted from is DP0. The one we're writing to is DP1. So we'll give it DP1, say yes that we want to install the bootloader, and it writes the bootloader to the disk. From here, the software is kind of dumb. To quit, we have to tell it a drive again, but then answer no for it to drop to the bootloader file name prompt. Now we can properly begin the install. We're going to run mboot.sys. But this gets more interesting than it may seem at first. The next step in the setup process is to run a program called sysgen. This will ask us a series of questions about our hardware. What this does is build a file exactly like mboot.sys that contains all of the software, interface configs, and parameters for different hardware options. mboot.sys is configured as a minimum viable system. It can probably run on only the RAM included in the CPU card, though I haven't tested that. As a result, mboot.sys is very slow because of how it handles hardware access. What we are going to do next is build a system that can take full advantage of how this microNOVA is configured. The parameters we give it here are the files we're outputting to the second disk that will be configured. I'm not going to go through all of the options, but I'll cover the highlights. First, it wants to know how much memory we have. This is where the word notation that Data General uses comes into play. I have 32 kilowords in this machine. Then we get to one discrepancy with the manual and the software. It wants to know if this is a microNOVA, which it is, but then it wants to know what kind, because later there were different revisions. This manual is from before that, so we will just call it other, and then use the console debug. We then tell it we have a 6038 with 2 drives, which is what the 6039 technically is. We can't enable the hard drive yet, or it will hang on boot until I have it ready. The next few questions about stacks, buffers, and subdirectors influence how the computer uses the RAM to speed up normal actions. We're going to set them to the recommended values for a 32 kiloword system. The rest of the questions I can mostly say no to or accept defaults. After answering all of the questions, the computer then takes about 12 minutes to actually build the system file. I suspect a good part of this is just from the mboot sys system being so low spec. After that finishes, there are a few more files that we need to copy to have the command line on the new disk. After that, it's possible to reboot directly to the new disk without removing it, but I want the full experience. So I'm going to release both disks, and then I can put the new disk in the left drive and run 33L to boot it again. Now I can just hit enter because it will boot the sys file automatically. And after the date, we are into our brand new configured system. If I list the startup disk in the other drive, you can see just how much faster the machine is now. We now have a bootable operating system. So, what now? Well, this is the eternal problem with a business system like this. You're expected to write your own software. There isn't anything out there that's really that exciting that I can run to demonstrate this computer. Now, there are a handful of things to run on this, but they're all like programming languages like Fortran, COBOL, and the utilities disk that we wrote actually has an assembler for DOS on it. Now, there is one thing I would like to get on here, and it would make it a lot easier if I ever try to use any of those to write my own programs for this. And that is CRTEdit. Most of the text editors made for these machines are assuming that you're using something like a teletype, because you wouldn't want to do a full screen redraw every time you started updating the text. So they only draw one line at a time as you work on the machine. This meant that you had to keep the entire document in your memory as you were working on it, and that's a huge pain. CRTEdit was included with interactive COBOL, and based on the manual, should be a screen editor. So let's try getting that running on here. It is also on a mag tape, so I have to go back to SimH, extract the data to a hard drive, and then I need to get the files for it onto a new floppy disk image. I can then write that to a floppy, and we can give it a shot on the real hardware. All right, I should have a bootable copy of CRTEdit on here. I made the disk bootable because if I booted off of the main disk, then I would have to put this in the secondary drive. And then if I wanted to have a data disk, I would be screwed because I can't actually take out the boot disk when we're working with the machine because it needs to be able to write cache data for like everything there. So the CRTEdit program or any program that you actually want to run needs to be on a bootable disk. All right, give me the prompt where I can list and see that I have CRTEdit on there. Excellent, which we can now run on the microNOVA for the first time. Oh, yes! Okay, that's pretty sweet. This is fully the first time I've ever run this, so this is genuinely exciting. Actually, for giggles, let's see what we can do here. So this is a typing test on the Data General microNOVA. Why did carriage return not do anything? New line? No. Oh, does it just start at the bottom and then continue? That's really weird. Why is the cursor in the top and then not anywhere else? All right. Here, I have disabled alpha lock key so I can demonstrate lowercase characters. Oh, it doesn't word wrap. It says no thank you for word wrapping. Fine, this is what I wanted to do. I want to open the sysgen SG file because that'll have a bunch of text in it. So I was gonna go do this after I figured out how to close. So CRTEdit sys.sg. Oh, that's awesome. That's perfect. I can go up and down through it too. Okay, this is actually pretty awesome. Like, it's the most bare bones basic thing you would think you would ever need for a computer, but like, to like know I actually have it, that's pretty darn good. This is definitely not a guaranteed kind of thing that you would have on a data general, so that's really, really nice to see. So this file that I opened is a record of my answers for generating the system that runs on the machine. So I can go through this to see what all was used to configure this machine. So that's a handy use case for this. You could also just print this to the screen, but this would, in theory, allow me to edit this file too. The editing is a little odd though, because everything you type ends up getting put down here. This is the editing area. To execute that, illegal syntax, yeah, it's, I'm gonna have to learn a lot more about how to use this software before it's actually usable, but I think I can actually use it, so that's pretty sweet. Well, all right, I think we're at the end here of what I can demonstrate with this machine right now, but that's a working data general microNOVA. Oh my gosh, I still can't believe it. After 5 years and I think over 100 hours of work on this machine now, there it is, it's running, it's working, it's fully functional. I mean, the hard drive still needs work. I'm getting in the part for the second async card, but that is a usable machine. It is so nice to be in this position that I can now say that that computer is done. Now, I'm not done because we haven't touched this at all, and there does seem to be some confusion about this, so let me reiterate this. This cabinet is a data general microNOVA. This cabinet is a Nova 4X. This is an entirely separate computer from the microNOVA. It's from the Nova family, but that one is going to take its whole own series to get going, and it's probably going to be a lot harder because there is a lot more going on in this machine, and I don't have floppy drives for it. I would need to get my hands on a 6030 floppy drive to be able to use the same kind of floppies I use on this machine with this one. Until then, not exactly sure how I'm going to bring this one up now that I've used that, because getting software onto that isn't going to be easy. Paper tape might be my best option, and I do have a way of doing that now, but that is going to have to happen far in the future. I think it's time for a bit of a data general break on the main channel. There are a few things I'm going to finish up over the next couple of weeks, like the serial card, and I'm going to try to refurbish that keyboard that I was sent by Bill and Commodore Z. But I'm going to leave the hard drive for now because that's going to be a massive amount of work, and I might even be better off trying to get this machine going before turning on the hard drive, because I have a second one of that hard drive right there, and that one is probably a lot less risky to try and archive the files off of than the microNOVA one, which likely contains an unarchived copy of an earlier version of the operating system that I would really like to get backed up. But for now, I get to call the machine done, and I get to relish in the fact that it works. Well, if you enjoyed this data general series, I really appreciate it. Thank you so much. It's been a long time coming, and I feel incredibly privileged to have been able to hold on to these machines for so long to be able to finally get to the point where I was ready to get them running. Man, has it been rewarding. So thank you. If you want to help support the channel, I am on Patreon, but for now, that's it. And I will see you next time.